Good morning. We're back here. Short video today. Just want to review kind of what we've gone over, and then I want you to do whatever you need to get ready for the test tomorrow, whether it's chapter 12 review, looking over your old test, finding some problems out of the book that match that, looking at the formulas, memorizing the formulas. Okay, so just chapter 12 skills tomorrow. Okay, why don't you take a look at these 5 problems, see if you can do them, maybe with a partner, check your answers with the group, and pause it here, and I'll come back and work through them. Okay, we talked about probability yesterday, but really probability is a counting question. It's just 2 counting questions, one for the numerator, one for the denominator. That's how you get probability. So if you're solid in your counting, you should be all right with your probability. So that's where we're going to start today. Number 1, assume the pattern must stay the same. Numbers and letters. How many license plates could California have? So here's an example, and this is a choices problem. You've got a number choice to which there are 10, a letter choice to which there are 26, 26, and 26, and then we've got 3 numbers, number, and we obviously can see in this one that the double 9 things can be repeated, and so you're just looking to multiply those things together. We could write this quicker or in a little bit abbreviated. That's not a little abbreviated version here. 26 to the third, and that's gonna be a pretty big number. But I would like you to multiply it out. So give me that final number there, because you'll need to use that in a probability type question. So what's the probability you get this exact license plate? One out of this 1,775 million. Okay, number 2. To buy a computer system, a customer can choose one of 4 monitors, one of 2 keyboards, one of 4 computers, and one of 3 printers. Determine the number of possible systems that a customer can choose from. And again, it's just simple counting. We've got, I think, 4 different choices here. One of 4 monitors, one of 2 keyboards, one of 4 computers, and one of 3 printers. So we're going to multiply it together, those choices. 4 times 2 times 4 times 3. For a total of 96 choices. Number 3, how many 5-card hands contain 3 diamonds and 2 clubs? Alright, so now we're not so much picking choices. We've got essentially 2 things that need to happen. The first thing that needs to happen is for me to get my pen out and not the highlighter. The first thing that needs to happen is we need to get some diamonds. Alright, so we need to get 3 diamonds. There are 13 total diamonds in the deck, and it doesn't matter which 3 we get, and it also doesn't matter the order in which we get them. And so that's why we are going to use a combination here. There are 13 diamonds. We need to choose 3 of them. Order does not matter. In the end, if you get an ace first, a 2, and then a 3, it's the same thing if you would have got a 3 first, an ace first, or an ace second, and then a 2 last. It doesn't matter. So it's 13 twos 3 times. When I return, we're going to talk a little bit about this word and. And always implies multiplication. Okay. So we're going to multiply, and then the ways to get the clubs. And it's really the same idea. There are 13 clubs, and you need to choose 2 of them. So we'll multiply 13, choose 3, times 13, choose 2. About 22,000 different ways. So this takes care of all the club or all the diamonds, all the ways you could get different diamonds, all the ways you could get different clubs. Order really doesn't matter in this situation. So if we would have moved this to the other side, it would have been the same answer, because we're not really looking at, getting a diamond first or getting a club first. We just need to get those 2 things. You're making a bead necklace. You have 12 distinct beads, and the pattern calls for 5. How many unique necklaces can you have? On a test situation, I'll be very clear, like this is going to be a permutation, or this is going to be a combination by the words that I choose. This one is a little bit ambiguous, a little bit unclear. I would say that when you're making a pattern, a word like this, pattern, kind of implies a little bit of an order, like it matters. So I'm going to call this a permutation. We've got a total of 12 beads. We are going to choose 5 of them. The order or the pattern in which we place these beads matters. So it would be a different order had we placed them in a different combination or a different way. Excuse me. And this is 95,000. All right, and the last one. You're going to select a prom group. 9 couples attending and only want to select at most 4 couples. So prom drama, you know how that goes. How many different total groups could you create to attend prom? Well, I've capitalized perhaps the most important thing about this, and it's the at most. So at most 4 couples means you could go with none couples. Okay. Just you and your date. That's romantic. Okay. You could go with 1 other couple. Maybe you got your BFF and you and their date are gonna go. You could go with 2 couples. Okay. Maybe you want to split the costs a little bit on that limo or whatever you're doing. I don't care. 3 couples. And then finally, maybe 4. At most 4. You're not going over 4. Okay. Too big. Anything over 4, too big. And I guess I should keep using the word other. I guess other. So you're going to select at most 4 couples. Alright, how many ways can you choose nobody? The answer is 1 way, and that's just to choose nobody. But we can always use a combination for that. So we can say 10, choose no one, and you've got 1. So that might be your prom situation. 1 other couple means you've got 10 choices, and you're going to choose 1 person to go with, or 1 couple to go with. So there's 10 ways. You can do that without a calculator. Just choose 1 of them. Okay. With the 2 other couples, this is probably where you will have to get your calculator out. 10, choose 2. This is 10, choose 3. and this is 10 choose 4. Okay, because it doesn't matter the order. That's why we're using combinations here. It doesn't matter the order. All that matters is who's going. So 10 choose 2 is 45. 10 choose 3, 120. Excuse me. And 10 choose 4 is 210. And all of this will be your total. Okay. So you have 386 choices. Make sure you make good ones if you're going to prom.